Hello friends, subscribers and new viewers of this channel, and welcome to Machine Learning, Large Language Model and AI tutorials. In this tutorial, we explain how to download, install and run locally DeepSeek Janus-Pro multimodal understanding models. We explain how to install models on Windows and how to run models in Python. Since a lot of viewers of this channel are not familiar with AI models, first let's explain what are the multimodal understanding models and multimodal deep learning. Multimodal understanding is the ability to interpret, analyze, describe, and understand multiple and simultaneous sources of visual, sound, text, information, and data. In other words, multimodal understanding or multimodal learning is a branch of deep learning that integrates and analyzes simultaneously different types of data such as audio, images, videos, and text. These different types of data are usually called modalities. Janus-Pro is a multimodal understanding model. It can be used for image generation also. It comes in two sizes, 1B model and 7B model. In this tutorial, we will explain how to use Janus-Pro for multimodal tasks, and in the next tutorial, we will explain how to use it for image generation. Before we start with installation, let us first briefly explain the main ideas of the model. A multimodal model works like this. We provide to the model an image. For example, let's say that we provided to our model this image, and in addition to this image, we ask this question. Describe the image, and is the entity on the image dangerous? So the model should be able to understand the image, recognize the text, and answer this question. And this is the real answer of our model, and I will explain how to generate this answer later on. And let's see what's written. The image depicts a futuristic scene with a character that resembles a dog wearing advanced armor and wielding a weapon. So the model was able to first of all recognize that this animal over here is dog. The background features other armored figures and flying drones, suggesting a combat or training environment. Excellent. The text on the image reads ROS2 training and courses, so you can see that the model was able to recognize the text, indicating that the image is likely related to training or educational content for ROS2, a robotics operating system. So you can see a very high level of understanding images and understanding context. And this is super important. Regarding the entity's danger, this is related to the second question. The character appears to be equipped for combat, suggesting it could be dangerous in a hypothetical scenario. And this is super important. However, the image is clearly a fictional representation and not meant to be taken literally. So you can see how deeply the model can understand this image. The model was able to recognize that this is probably commercial, that is, this is not a real image, and this is truly amazing. So here are some important comments and remarks. First of all, we will install the Janus-Pro on a Windows computer. To correctly install the model, you will need to install Microsoft Visual Studio C++, compilers, and NVIDIA CUDA toolkit and compilers. This is necessary for properly installing and running PyTorch. Then, we will explain and create a simple Python script for running the model. Link to the code will be provided in the description below this video. Note that online instructions for installing the model given on the GitHub page are mainly written for Linux systems and for Linux users. Consequently, we will have to make significant modifications in order to be able to run the model on a Windows computer. And before we start, here are our computer specifications. We are running the model on NVIDIA 3090 GPU, Intel i9 processor, and 64 GB of RAM. And as you will see later on, it takes no more than several seconds to generate the response once the model is properly loaded in the computer memory. Okay, that's it. This was the introduction, and let's start with installation instructions. Okay, first, we will explain how to install the prerequisites that you need to have in order to successfully run this model locally. First of all, you need to have Microsoft Visual Studio C++ and Microsoft C++ compilers. To do that, open Google and search for Microsoft Visual Studio C++, then click over here, then scroll down and expand this menu and click here on a Community Edition. And the file will be downloaded. click on the Downloads folder, save it. Now, install Visual Studio. Its installation is very simple, and once you do that, you need to proceed further. Next, you need to install NVIDIA CUDA Toolkit. To do that, search for NVIDIA CUDA Toolkit, click over here, then click on Download Now. Then you need to select your operating system, Windows, Architecture, Windows version, and over here click on Executable Local and download the file. After you download the file, click on Download, install the file, and make sure that you add NVIDIA CUDA Toolkit to your system path. The next program that you need to have is Git for Windows. Consequently, open Google and search Git Windows. Then click over here and download this Git 64-bit file for Windows. You will need Git to download the remote repository of this project. Once you do that, you can continue watching this video tutorial. Okay, let's start with installation. First of all, open a command prompt. Click here and search for command prompt. Then over here, I'm going to resize this window such that you can see what I'm typing, and at the same time, you can follow the commands that are written over here. Okay, this might be more difficult than installing into Linux. First of all, let's verify that we have NVIDIA CUDA compiler. So simply type this and you should see a response that looks like this. You can see that I have CUDA 12.6, however in your case you might have CUDA 12.8, however it really doesn't matter the compiler version as long as it is relatively recent one. Okay, so let's double check that we have Git. If you have properly installed Git, you should get this response, and let's start with cloning the remote repository. First of all, let's go to the base C drive, and over here we need to clone the remote repository. So this is the address of Janus. So let's go here and let's see the GitHub page. Here it is. Now, here on this GitHub page, you have all the files and folders that are necessary to install the model. However, you still need additional files, and I will explain later on. Now, what is very important to observe here? Here you have some instructions which are only partial instructions. They don't explain a lot of things. They don't explain that you have to download using Git, then you have to download the models from from Hugging Face. Then over here you cannot just run this command since it's not going to work on Windows, or it might work, however PyTorch will not run. There are a bunch of modifications that you need to perform, and I will explain them later on. The reason for this is that people who are usually developing machine learning software are used to Linux operating systems. However, the users are mostly using Windows, and there is always some gap between that because people who are very technical, they are very good with Linux. However, users, they are not usually very good with Linux and they prefer Windows. I know both Linux and Windows, and for me it really doesn't matter. Okay, so let's start. First of all, copy this address, then go to the command prompt and type git clone and then this address. So what will happen now? You're going to completely download everything from this GitHub page, and a new folder will be created on your C drive. So let's execute this, and here it is. Now, if you type cd Janus or Janus, you will see that all the files are perfect copies of the files on this GitHub page. Okay. Now, inside of this folder, we are going to create two subfolders. First of all, we are going to create the folder model 1, and we are going to create folder model 2. These two folders will be used to download the first model and the second model. So let's see what are the first and second models. Namely, if you go to this GitHub page, and if you click here, you will be there, and here you will be directed to these two GitHub, or better to say Hugging Face repositories. The first one is Janus-Pro 1B parameters. This is a smaller model which only has 1B parameters, and the second one is Janus-Pro 7B. This is the largest model which has around 7 billion parameters. Okay, now we are going to install both of these models. The smaller model will be stored in the model 1 folder, and the larger model will be stored in the second folder. The next step is to create a Python virtual environment. However, to do that, you need to have Python installed on your system. So type Python version, and I assume that all of you have Python installed on your system. If you don't have Python installed on your system, simply Google here, go to Google and search for download Python. And you will be basically directed to the web page, and you will be able to download Python literally with a single click. Okay. Let's continue. To create the Python virtual environment, make sure that you're in this base folder and type this. And this will create a new folder, environment1. This folder, let's see the folder, where is environment1? Here it is. This folder will contain all the configuration files as well as all the packages and library files. The next step is to activate this environment. To activate this environment, you need to type this. And as the result, you will see in parentheses environment1. This means that your Python virtual environment is activated. The next step is to install a library that will help us to download the two models from Hugging Face. Here's how we install the library. We need to type pip install Hugging Face _hub and press enter. In fact, this library contains a number of packages that are necessary to download the models. The next step is to write a simple Python script that will download the remote models from Hugging Face. In this video tutorial, I'm going to use Visual Studio Code. That's my favorite Python editor. And I created a separate video tutorial explaining how to install Visual Studio Code, and a link to that tutorial will be given in the description below this video. So let's start this. And let's create a new file, new file, and I will call it as download.py. Okay, and let's save it in this folder, and let's type the file content. Here, to save time, I'm simply going to paste the download script, and let's explain what we are doing over here. From Hugging Face Hub, we are importing this function for downloading the remote repositories from Hugging Face. And over here, we need to adjust the Hugging Face name of the repository. Consequently, go here to the first model, copy this part over here, paste the part over here, and over here, adjust the path. Namely, what's happening over here? Here you need to specify also the local directory where you want to download the files. Note one very important thing. You need to write double these backslashes, and this is the convention for Python. If you just write a single one for path, this will not work. In Linux, you'll write something like this, right? Home, then your username, etc. However, Windows works differently, and this is very important to keep in mind. Now, if you want to see what is the path, here in this folder, there is another folder called model1, and there, in that folder, we are going to store the files for the first model. Okay, so let's run this script, but before we run it, we have to make sure that Visual Studio Code is using the correct Python interpreter. That is the Python interpreter inside of our virtual environment. To do that, press and hold Ctrl, Shift and P, then search Python, select interpreter, and over here make sure that you select this interpreter, and here you can run the code, and let's see what will happen. You see now the files are being downloaded. You see over here that you're downloading around 4 GB of model weights, and consequently be patient since it's going to take a while to download everything. Okay, maybe after several minutes the model is downloaded, and let's download the second model. To download the second model, let's go back, let's go to the web page of the second model, copy this, then go over here, paste the name of the repository, and here modify the model directory, and then save the file. Do again Ctrl Shift P, Python select interpreter, make sure that you're using the correct interpreter, and run the file. And over here you're actually downloading around 15 GB of model weight, and this might even take longer, let's say 5 to 10 minutes, depending on how fast is your internet connection. Now, if you blindly follow the instructions given on the GitHub page of Janus-Pro, then after downloading the model, you would have to run this command. Now, if you run this command in the command prompt, yes, you'll be able to install the libraries. However, after you run the test code, you will see that the errors will be generated. And the error will look like this. Raise assertion error, torch not compiled with CUDA enabled. Assertion error, torch not compiled with CUDA enabled. And this is the issue. So what is the issue over here? Well, the issue is that the command pip install -e dot will actually follow the instructions for installations that are given in the files that we will show right now. So let's go to C, let's go to Janus, and there are two important files over here. The first file is the file that defines the requirements. So if you open up the requirements file, you see over here, this command, or better to say, this requirement refers to PyTorch and it gives you the version. However, the issue over here is that you are not installing with CUDA support, and this is the issue. Maybe for Linux Ubuntu it's going to work, however here it's not going to work. So the first modification, let me show you, is to find the requirements file in the workspace folder. Here it is, enter it, and erase this line. Okay. We are going to install PyTorch, however, we are going to follow the official procedure for installing the PyTorch. So this is the first modification. Now be careful. There is a second modification. In addition to this file, you also need to edit an additional file. An additional file is pyproject.tml. So this file is actually being called with the command install. So again, let me now close this. So if you now edit this file, so I will just double click and it's going to open in Visual Studio Code. Here you should see the dependencies. And if you see the dependency over here, you will see the torch dependency over here. Consequently, erase this dependency and make sure that the file looks like this. Here, for this optional dependencies, you don't need to touch anything, and over here, don't touch anything. That is, here in the dependencies line 15, erase torch. Okay, so let's save this file, close the file, and the next step is to manually install PyTorch with CUDA support. To do that, let's go to google.com and let's search install PyTorch locally. So click here and click on this link, or directly go to this website, and this website will generate this table for generating the command that will install PyTorch. So click here CUDA 16, make sure it's stable, make sure it's Windows, make sure it's pip, Python, and this. And then this command will be generated. Copy this command, then go to command prompt and execute this command in the Python virtual environment. And here it is. Now PyTorch is properly being installed, and you're installing PyTorch with the CUDA support, and this CUDA support will actually depend on Microsoft Visual Studio C++ compilers, DLL libraries, as well as the installed NVCC compiler. So this is the proper way of installing PyTorch. After PyTorch is properly installed, let's run this command. And here it is. Okay, now we are installing all the dependencies written in these two files. That is in the requirements file and in the another file. And this might take a while. Okay, so let's be patient. And finally, after everything is installed, let's type pip list to verify that we have everything. I can see transformers, I can see torch, torch audio, torch vision. Good. The next step is to write the test code. Go back to Visual Studio Code, click on File, New File, and call the file as test.py. Here it is. Okay, save it in this folder, and over here, to save time, I will simply paste the content. And let's explain this file line by line. Again, this file is based on the modified file that's given over here on the official web page. I made several important modifications such that I can execute this file on the Windows computer. Now, let's go back and let's see what's written over here. First of all, we need to import torch, and we need to import these libraries. And then over here, you need to specify the path to the model. In this particular case, I will use the model that's stored in the folder model2 inside of the folder. And note over here how we write the path in Python for Windows. This is completely different way for writing the path in Linux. So over here, we create VLChat processor, we create tokenizer, then over here, we load the model. Here we set up VLGPT, and here we ask a question. Describe the image and its entity, and is the entity of the image dangerous? Over here, you can actually change the question. And again, yes, I'm going to provide a link to this file in the description below this video. And over here, you need to specify the image. So you need to create or take an image, and I will show you the image I'm using. Here, you need to copy the image to the workspace folder. That is, you need to copy the image to Janus. So let's do that. My image is actually in the downloads folder. Here it is. Let me just open it here. And then I'm going to copy the image, and then I will go to the folder, this PCC Janus, and I will paste it over here. And make sure that the file is copied. Let's see where it is. Did I actually copy it? I actually didn't even copy it. So let me copy, Control C. Then let me go to the folder again. Here it is, and then I'll paste it, and here it is. It's called test1.png. Very important to keep the extension. I think that you can also use the JPG files. Okay, so enter precisely the name of the file. If you store the file somewhere else, you need to add the path to that file by using the same principle as the principle for defining the model path. And over here, you define the conversation list. Inside of this dictionary, you specify your role. Here is the content. You put the image placeholder and you put a question. That is the string over here. And over here, you give the image to this model, and then you specify your role, and that's it. Then over here, you load images and prepare for inputs. And over here, you do additional things. Then you run the image encoder to get the image embeddings. And over here, you run the model to get the response. You can maybe play with some of the parameters over here to improve the performance. And then over here, you generate the response. And finally, you print the response. And that's it. Now, as I mentioned previously, I will provide a link to this file in the description below. Okay, so let's save this file and let's try to run it. To run this file, press and hold Ctrl-Shift-P, search for Python Select Interpreter, make sure that you select the correct interpreter, and after that simply click on Run, and the file should be executed. So let's see what happens. Now, let's wait. The first thing that will happen is that the model will be loaded, and this might take a while depending on how fast is your computer and your GPU. While the model is loading, you can also open a task manager to see the consumption of resources. Here you can see, let me see, here you can see actually that the model is being loaded, and then you see what's happening with GPU. GPU memory is over here, GPU processor is over here, and let's wait until the model is being loaded. Wait for a while. Let's see. Here the memory was basically almost half full. Then you can see GPU was doing something, and the response is generated. The image depicts a futuristic scene with a character that resembles a dog, etc. That is, the response is generated over here, and you can save this response, for example, in a text file. You can simply get this string, save it in a text file, or you can display it on a computer screen. Okay, that's all for today. I hope that you like this video. If you like the videos I'm creating, please press the like and subscribe buttons, and see you in the next video tutorial.